Welcome to the channel. If you are interested in space, science, deep questions, and the real nature of the universe, you are in the right place. Here we go beyond simple facts and explore ideas that change how you see reality itself. Before we begin, make sure to subscribe to the channel. New videos are released regularly, and subscribing helps you not miss the next journey into the unknown. If you enjoy thoughtful, high-quality content, a like is the best way to support the channel and help this video reach more people who are curious about the universe. And now, let us begin. 300,000 kilometers per second. A number you were forced to memorize in school like a sacred mantra, nature's greatest achievement. The absolute record, the holy symbol of speed. They taught it the way you teach a child the height of a mountain. With admiration, with a hint of pride, as if simply knowing the number makes you closer to the sky. But nobody, what it really is. Nobody said out loud that this number is not a gift. It's a sentence. Not freedom, confinement. Not hope and execution signed by the universe long before the first star ever ignited in primordial darkness. Light is the fastest thing that exists. And that is precisely, we are trapped. We live on a small blue point drifting through an ocean so large that distance stops being a measurement and becomes a kind of cruelty. Tonight we're going to walk into three mysteries bound to that cosmic limit. First, why the physics of reality itself quietly forbids any human lifetime from escaping the neighborhood of our Sunday. Second, how space and time become walls, not merely difficult to climb, but mathematically merciless. Third, what this limit means for the fate of humanity, for the question of alien intelligence, and for the most terrifying concept of all, loneliness at the scale of the universe. What you're about to learn changes the night sky, not because it makes it uglier, because it makes it honest. Every star you see becomes something else, not a beacon, a reminder. Every galaxy becomes less an invitation, more a distant laugh echoing across distance you cannot cross. Let's start with the story you were handed, the version that fits inside textbooks and glossy documentaries. The speed of light is the universe's speed limit, they say. Nothing can go faster. A fundamental law described by Einstein's relativity in the early 20th century. Photons travel from the sun to Earth in about 8 minutes. Light from the moon reaches your eye in a little over a second. It's absurdly fast by human standards. And then comes the sedative, the lullaby. Someday, they imply, we'll find a way around it. Hyper jumps, it's only a matter of progress. Science fiction trains your brain to treat interstellar travel like engineering. Complicated, expensive, but ultimately solvable. A puzzle, with enough time, that picture is comforting. It lets you look up and dream of a future where humanity spreads through the galaxy like a tide, where every bright point becomes a destination. It turns the stars into real estate, but that picture is a lie, not because scientists are lying, but because the truth is usually delivered without its consequences. No one sits you down and forces the numbers to hit your nervous system. Here's the first thing that gets hidden behind the beautiful phrase, cosmic speed limit. 300,000 kilometers sounds enormous, but the universe is built so that it is almost nothing. The nearest star system, Proxima Centauri, is over 4 light-years away. That means even light moving at the maximum possible speed needs more than 4 years to get there. 4 years of non-stop flight at 300,000 kilometers every second. Now imagine we build a spacecraft, not a realistic one, a perfect one. The best engine you can dream up without breaking the known laws of physics. Let's be generous. It reaches 10% the speed of light. That's 30,000 kilometers, a speed that feels divine. At that velocity, you could circle Earth in under a second and a half. You could reach the moon in roughly 13 seconds. It would make every speed you've ever experienced feel like stillness. And yet the trip to Proxima Centauri would still take over 40 years. Years. A human life. An entire lifetime measured not in adventures, but in a single corridor of black with no stops, no rescues, no shortcuts. No, we'll turn back if it gets hard. Astronauts launched in their prime would arrive as old, if they arrive at all. And this is the closest star, the cosmic neighbor, the one you'd point to as right there. But reality is worse. We can't reach 10% of light speed with anything like a crude ship. The fastest human-made object, boosted by gravity and pushed by the sun, is a solar probe that reached on the order of a few 100,000 miles per hour, only a tiny fraction of light speed. At those kinds of speeds, a journey to Proxima Centauri isn't 40 years. It's thousands, many thousands. Civilizations rise and fall in that span. Languages rot into history. Borders become dust. The people who launched the mission become fossils in forgotten museums. And that's still just one star away. The Milky Way contains hundreds of billions of stars and spans about 100,000 light years. Even if you could move at the speed of light, which massive objects cannot crossing our own galaxy would take 100,000 years. The nearest large galaxy, Andromeda, is around 2.5 million light years away. Light itself needs 2.5 million years to cross that gap. Now, you can feel of the trap. The speed of light is not a ceiling you struggle to reach. It's an architectural feature of reality. Space and time are sewn together so that anything with mass cannot reach that speed, let alone exceed it. And here's the second layer, the part that turns this from difficult to merciless. The faster you go, the more energy you need to go even faster. Not a little more. Not double the speed, double the energy. It's not linear. It's a curve that becomes a cliff. As you approach light speed, the energy required for additional acceleration climbs toward infinity. Not metaphorically in the mathematics itself. A truly infinite demand. To accelerate any object with mass to light speed would require infinite energy. That's not a technological hurdle. That's not we just need better engines. That's a wall woven into the equations. Think of chasing the horizon. You walk toward it, you run, you sprint with everything you have, but it keeps sliding away because it's not a point you can touch, it's a relationship between you and the world. The speed of light works like that. Not a barrier sitting out there, but a property of reality that retreats as you approach. The universe doesn't say you may not pass, it says there is no passing. And then comes the third layer, the one science fiction whispers about, if it mentions it at all. Even if, by some miracle, you solve the energy problem, if you somehow built a ship that could reach a significant fraction of light speed, you would collide with a different kind of nightmare. At near light velocities, space stops being empty. Interstellar space contains hydrogen atoms on average, roughly 1 atom per cubic centimeter. That's essentially nothing by Earth standards. When you move at tens of thousands, or hundreds of thousands of kilometers per second, each of those atoms becomes a bullet. At 10% the speed of light, impacts with single atoms start to carry the sting of gunfire at microscopic scales. At half the speed of light, each collision becomes closer to a bomb. At 90%, the thin and interstellar medium turns into a lethal storm of radiation that would shred known shielding, and hydrogen and, the worst of it, dust. The interstellar medium contains dust grains, tiny fragments from comets, asteroids, the condensed debris of exploded stars. They're smaller than the thickness of a human hair, sometimes smaller than bacteria, but at near light speed, a dust grain is a nuclear event. Picture a ship flying to Proxima Centauri at half the speed of light. Every second it covers 150,000 kilometers. Every second its nose is bombarded by countless atoms and particles, each carrying monstrous kinetic energy. The ship doesn't probably survive. It doesn't survive. Could you build protection? In theory, yes. Magnetic fields might deflect charged particles. Thick shielding might absorb impacts. But shielding adds mass. More mass demands more energy. More energy requires more fuel. More fuel adds more mass. A vicious circle. This is the tyranny of the rocket equation. Every extra kilogram you want to carry demands exponentially more propellant. For interstellar travel at relativistic speeds, the fuel mass becomes absurd planet scale, perhaps star scale before you even start talking about life support, crew safety, or heat management. That's the brutal arithmetic of the cosmos. The universe made light fast enough to let us see the stars, to let us measure them, analyze them, discover planets' inhabitable zones, and yet slow enough to keep them permanently out of reach. A transparent cell. You can study what's outside, you can watch it glow, you can map it and name it and write equations about it, but cannot step through the wall, and the cruelest part is that you know it. An animal in a cage does not suffer from the knowledge of its captivity. A rational mind does. The universe gave us intelligence large enough to recognize the size of the world. and then chain that intelligence to a single tiny rock. Is it an accident? Or cosmic irony? Physicists will tell you it's just reality. Vacuum permittivity, electromagnetic constants, the geometry of spacetime. Cold math without intention, and yet when you stare at how perfectly this limit isolates any civilization, it becomes hard not to feel something like design. There's a famous answer to the Fermi Paradox, the zoo hypothesis, sometimes framed as a present hypothesis. The idea that civilizations are isolated by higher beings or by the structure of the universe itself. The speed of light is a perfect lock for that kind of isolation. It lets you see without touching, know without meeting, dream without arriving. If the universe is a prison, light speed is the door bolt. But the darkness doesn't end there, because we haven't even touched what happens to time itself. When you try to approach the limit, Einstein didn't just give us a speed limit. He gave us a universe where time is not a single river, but countless streams flowing at different rates depending on motion and gravity. Time, absolute. And once you accept that, speed of light becomes more than a distance problem. It becomes an exile machine. Relativity says that the faster you move, the slower your time passes relative to a stationary observer. At everyday speeds, this effect is tiny airplanes, satellites, even rockets only gain or lose fractions of a second. But as you climb toward light speed, the effect grows violently. At 90% of light speed, time on the ship ticks about half as fast as on Earth. 99%, it slows by about a factor of 7. At 99.9%, more than 20-fold. At first glance, this looks like a loophole, almost like mercy. If we can't beat the distance, you might think, we'll beat the clock. A traveler moving near light speed can cross huge distances while experiencing relatively little time. A voyage of 4 light-years to Proxima Centauri might take a bit over 4 years for Earth. But for a ship at 99% of light speed, the crew might feel less than a year pass. That sounds like a dream. Here is the price. When the traveler returns, Earth has moved on without them. Relativistic time dilation turns interstellar travel into a one-way ticket, not in space, but in history. Imagine you leave Earth on a relativistic mission. 10 years pass for you. You come home and discover 3 centuries passed on Earth. Your friends are dust. Your city is a myth. Your language sounds antique, like a recording from a museum. Your culture is a chapter in a history book. You are alive, but you are displaced and immigrant into the future. Science fiction often skips this. Heroes fly out, fight aliens, return to the same home, the same people, the same era. Reality is colder. If near-light travel is possible at all, it means separation so deep it becomes a kind of death. Even if your body returns, your life does not. The speed of light doesn't just lock you inside a region of space. It fractures the meaning of together. It breaks the idea of a shared timeline. And even this loophole is mostly illusion, because to reach those speeds you still need energy we cannot produce, shielding we cannot build, and engineering that fights every limit of thermodynamics. So yes, you might cross the stars by cheating your own clock, but you cannot keep your world. Now take one more step into the dark. The speed of light isn't only the limit of travel, it is also the limit of information. No signal, radio wave, laser pulse, gravitational can outrun light. That means even if a civilization spreads across many stars, it cannot stay unified. Communication delays become geological. A message to a colony 500 light-years away takes 5 centuries to arrive. The reply takes 5 more. A single exchange, 1,000 years. That's not conversation. That's 2 monologues separated by the erosion of civilizations. Centralized control becomes impossible. There can be no true galaxy-spanning empire with a single government issuing orders in real time. A capital world would be a relic by the time its decisions arrived. Each colony would drift into independence not by rebellion, but by physics. Languages would diverge until they became mutually unintelligible. Cultures would mutate into alien forms. Biology itself could split different environments, different pressures, different technologies sculpting different humans. The speed of light guarantees fragmentation. And that has a chilling implication for the silence we hear when we listen for other minds. Maybe the universe is not empty. Maybe it's crowded. Maybe millions of civilizations are out there, staring into their own skies, asking the same question we do: where is everyone? And the answer could be, everywhere, just too far, too late, too isolated. All of us trapped in our own bubbles of space-time, separated by a limit that turns distance into solitude. At this point, you might want a concrete anchor, something human-made, something real, not just cosmic abstraction. So, let's talk about a machine you can almost picture in your hands. A small craft, not much larger than a washing machine, launched in 977 when computers filled rooms and mobile phones were science fiction. A messenger made of metal, crossing the outer darkness. Voyager. It has traveled for decades and is now the most distant object humanity has ever created. It has crossed the heliosphere and entered true interstellar space. It drifts through a region where the sun is no longer king. And how far away it is? Tens of billions of kilometers. Sounds absurd until you translate into the universe's true currency. Light time. Light covers that distance in less than a day. A signal from Voyager takes roughly a day to reach us. We command. We receive. We wait again. Even inside our own solar backyard, conversation becomes slow. Now compare. Voyager has flown for nearly half a century, using gravitational slingshots and every trick we know, reaching a speed of only a few tens of kilometers per second. In that time, has covered a distance that light would cross in hours. If light were a marathon runner, Voyager would be a snail crawling through frozen honey. And here comes the crushing scale. Proxima Centauri is 4.24 light-years away. At Voyager's speed, reaching it would take on the order of tens of thousands of years. 70,000 years is longer than all recorded human civilization. Humanity would have to reinvent itself twice before the machine arrived at the nearest star. Voyager 2, launched earlier, travels a similar fate also outside the heliosphere, also sending faint data through a growing gulf, also carrying a golden record. Music, voices, a message in a bottle thrown into an ocean measured in millennia. A romantic gesture, and tragic one. Because even if some civilization finds those probes, it will be so far in the future that the senders may be extinct or evolved into something unrecognizable. The message will outlive its language. The greeting will outlive the species. But humanity doesn't stop dreaming. Engineers propose bolder ideas. One of the most famous is a concept of tiny spacecraft grams in mass pushed by powerful lasers via ultrathin light sails. In theory, they could reach 20% of the speed of light. At 0.2 saliens, the journey to Proxima could take about 20 years. That's the first number in this entire story that sounds like a human plan. Launch, wait, receive data from another star within a lifetime. But the moment you say, 2 salient, the universe sharpens its knives again. At that speed, even sparse interstellar gas becomes sandblasting gunfire. Hydrogen atoms become relentless impacts. Dust grains become explosive events. The craft's surface erodes. Electronics glitch and fail. One collision with a grain the size of a bacterium can end the entire mission as a flash of plasma. The hope remains, because statistics might favor a tiny probe. Send thousands and maybe a few survive. Maybe, but notice the pattern. Every time we reach for a door, physics answers with probability, not certainty. Other proposals go further. Nuclear pulse propulsion, fusion drives, antimatter. Some are conceptually possible, but politically impossible. Some are physically possible, but economically absurd. Some demand materials and energy control far beyond our horizon. Antimatter is a perfect example. Annihilation converts mass to energy with maximum efficiency. A gram meeting a gram releases an explosion that makes human weapons look like toys. But we cannot produce antimatter in meaningful quantities. Even our most powerful accelerators would take unimaginable time to create a few grams, and at a cost that exceeds anything resembling a global economy. Antimatter is fuel for civilizations that are centuries or millennia ahead of us, if such civilizations exist at all. And then there are the cheats, warp drives, wormholes, spacetime shortcuts. These are not pure fantasy. The equations of general relativity allow strange geometries. A warp bubble could compress space ahead and expand it behind, moving a ship without locally exceeding light speed. A wormhole could connect distant points like a tunnel through folded space. But these concepts demand exotic conditions, negative energy densities, stability against collapse, control over gravitational extremes. They also carry catastrophic side effects, causality violations, time travel paradoxes, horizons you cannot see through, energies that could sterilize planets when released. The universe dangles escape routes like mirages. You run toward them, and the closer you get, the more the mirage dissolves into either impossibility or disaster. And we still haven't touched the darkest part, because beyond our local dreams, the universe itself is moving the goalposts. Space is expanding, and it is not merely expanding. It is accelerating, which means there are galaxies whose light will never reach us, not because we are too slow, but because the space between us grows faster than light can cross it. There is a horizon of the universe, an horizon not of a black hole, but of cosmology. Beyond it, the future is erased from our view. Most of the universe is already beyond that horizon, and with time, even more will slip away. If this is a prison, the walls aren't standing still. They are closing in. Most terrifying aspect of the speed of light is not how it limits movement. It's how it erases futures. Until now, we've talked about ships, engines, time dilation, and human lifetimes. But all of that assumes a static universe, one where space is simply there, waiting to be crossed. That assumption is wrong. Space itself is changing. The universe is expanding, not metaphorically, not poetically, literally. The distance between galaxies increases every second because new space is constantly being created between them. This was discovered in 1929, when Edwin Hubble noticed that distant galaxies were moving away from us, and the farther they were, the faster they receded. This wasn't motion through space, it was space itself stretching. At first glance, the expansion seems harmless. The numbers feel small, roughly 70 kilometers per second per megaparsec. Compared to the speed of light, it feels trivial, laughable. But that intuition is deadly wrong, because compounds with distance. The farther a galaxy is, the more space lies between us, and the more that space expands every second. At a certain distance, something impossible happens. The rate at which space expands exceeds the speed of light. Stop, let that settle. There are galaxies that are moving away from us faster than light, not because they're breaking physics, but because the fabric of space between us is growing faster than light can cross it. And here is the consequence that almost never gets emotional emphasis. Light emitted by those galaxies today will never reach Earth. Never. Not in a billion years. Not in an eternity. Even if the universe lasted forever, the light would still lose the race against expanding space. Those galaxies are beyond the cosmological event horizon. They exist, but for us, they might as well not. The observable universe, the portion whose light has had time to reach us since the Big Bang, contains on the order of 2 trillion galaxies. That number alone is staggering. But it is only a tiny fraction of the total universe. Depending on the model, the full universe could be hundreds of billions of times larger, or infinite, which means the overwhelming majority of reality is already unreachable. Not because of engineering limits, not because of energy shortages, but because of geometry. We are born on an island of visibility, floating in an ocean we will never touch. And the story gets worse. In 1998, astronomers made a discovery that shattered one of the last comforting assumptions. Expansion is not slowing down, it is accelerating. Some unknown component of the universe's dark energy pushes galaxies apart with increasing force. We do not know what dark energy is. We do not know where it comes from. We do not know whether it will remain constant or grow stronger. We only know its effect. The universe is being torn apart faster and faster. This means the cosmological horizon is not static. It is shrinking in practical terms. Galaxies that are visible today will one day cross that horizon. Their light will stretch, redden, weaken, and eventually fade beyond detectability. One by one, they will disappear. Not explode, not die, just leave. Imagine standing on Earth billions of years from now, assuming Earth still exists. The sky will look emptier. The familiar glow of distant galaxies will be gone. First the faint ones, then the brighter clusters. Eventually, only the stars of our local group will remain. Then those stars will die too. In that distant future, any civilization that arises will look at the sky and see almost nothing. One galaxy, a handful of stars, darkness everywhere else. They will conclude that the universe is small, static, and lonely. They will be. The evidence of cosmic history will have been erased by expansion. The Big Bang itself will become unknowable, not forgotten, but physically undetectable. The universe will lie to its own inhabitants. All of this is enforced by the speed of light. Light defines what can be known. Expansion defines what can no longer be reached. Together, they guarantee that most of existence is permanently sealed off. We don't live in the universe. We live in the part of it that hasn't escaped yet. Let's bring this scale back down to something that still feels almost human. Our own galaxy. The Milky Way is about 100,000 light-years across and contains hundreds of billions of stars. If you shrank it down to the size of a disk 100,000 kilometers wide, our entire solar system would be smaller than a grain of dust. Even inside our own galaxy, the speed of light is brutal. The nearest star systems after Proxima Centauri are still years away at light speed. Barnard's star, Lumen 16. Brown dwarfs drifting quietly in the dark, each separated by distances so large that even signals crawl. In 2017, astronomers discovered the TRAPPIST-1 system, a small red dwarf star with 7 Earth-sized planets, 3 of them in the habitable zone. It caused a wave of excitement. 7 potential worlds, liquid water, maybe life. The system is 40 light-years away. If we sent a signal today and received an immediate reply, the full exchange would take 80 years. A person who the first message in their youth might receive the answer in old age if they live that long, and that's still nearby by galactic standards. More distant systems, Kepler planets hundreds or thousands of light-years away, push communication into timescales longer than all recorded human history. Entire civilizations could rise and fall between hello and reply. Beyond the Milky Way, the numbers stop behaving like numbers. The Large Magellanic Cloud, 160,000 light-years, the Small Magellanic Cloud, 200,000, Andromeda, 2.5 million, Triangulum, nearly 3 million. These distances are not journeys. They are abstractions. You can write them, you cannot feel them. And that is the cruelty. We are smart enough to understand the scale, but powerless to overcome it. Try another analogy. Imagine that the speed of light is equivalent to driving at 100 kilometers per hour, the speed of a car on a highway. At that scale, the distance to Proxima Centauri would be tens of millions of kilometers, thousands of trips around the Earth, and that's the nearest star. At that same scale, Andromeda would require tens of millions of years of non-stop driving, 70 million years. Longer than the time since dinosaurs walked the Earth. And that's assuming are already traveling at the absolute maximum speed allowed. This is what the speed of light does to ambition. It turns dreams into equations that never converge. But what about shortcuts, you ask again? Warp drives, wormholes, hyperspace. Physics allows us to imagine them and then quietly destroys them. Warp drives require negative energy exotic matter that violates everything we understand about thermodynamics. Even if small amounts exist in quantum effects, scaling them to macroscopic levels looks impossible. Even worse, warp bubbles cannot be controlled from the inside. You cannot steer, you cannot stop, you cannot see what's ahead. And when the bubble collapses, it releases a catastrophic wave of energy in the direction of travel enough to sterilize entire planetary systems. A warp ship is not transportation. It is a weapon you cannot aim. Wormholes suffer the same curse. They require exotic matter to stay open. Without it, they collapse faster than anything can pass through. If stabilized, they introduce time travel paradoxes that likely violate deeper principles of reality. Every apparent exit becomes either unreachable or catastrophic. The speed of light doesn't just block us. It mocks us with theoretical loopholes that collapse under scrutiny. And all of this still ignores a quieter, subtler cruelty: information. Because even if travel were solved, communication would still crawl. No signal outruns light. No command propagates instantly. Any interstellar society fractures into isolated fragments. Coordination dies. Unity dissolves. And that may explain something unsettling. So silence. Maybe the universe is not empty. Maybe it is full of watchers. Civilizations trapped in their own light-speed bubbles, each seeing evidence of others but never touching, never speaking, never meeting. A cosmic archipelago of minds, each alone. And now, after all this abstraction, we return to something painfully concrete. A machine. A fragile artifact. A proof of effort. Voyager is still flying right now. As you read these words, it is moving away from the sun at about 10 kilometers per second. Its nuclear power source is weakening. In a few years, it will go silent forever, but it will not stop. In 40,000 years, it will pass within a couple of light years of another star. It will not slow. It will not arrive. It will simply drift onward, and extinct civilizations whisper carved into gold. A message sent by beings who knew it would almost certainly never be heard. And yet, they sent it anyway. Because when the universe gives you a prison, the only rebellion left is to leave evidence that you existed. So far, the speed of light has looked like a prison wall. A barrier that keeps us inside a small region of space, unable to escape, unable to touch what we can see. But here, the uncomfortable twist. That same limitation is also the only reason we are still alive. The universe is not gentle. It is not neutral. It is not a beautiful backdrop meant to inspire wonder. Beneath the glowing nebulae and elegant spirals lies a machinery of destruct so violent that, without limits, life would be erased almost instantly. The speed of light does not only restrict travel, it restrains catastrophe. To understand this, we have to talk about cosmic violence, not the abstract kind, but the kind that can sterilize planets. Start radiation. Interstellar space is filled with cosmic rays, high-energy particles accelerated by supernova explosions, neutron star collisions, and processes we still don't fully understand. These are not rays like light. They are bullet photons, atomic nuclei, electrons moving at speeds approaching that of light. Some of these particles carry energies far beyond anything our most powerful particle accelerators can produce. A single high-energy cosmic ray passing through a human body can damage DNA across hundreds of cells. On Earth, we are shielded by our atmosphere, by our magnetic field, by the heliosphere created by the sun's solar wind. Even so, astronauts aboard the International Space Station receive roughly 10 times the radiation dose of someone on Earth, and that's still inside Earth's magnetic cocoon. A mission to Mars 2 or 3 years outside, that protection already pushes human biology to its limits. Cancer risk increases measurably, cellular damage accumulates, and that's a short trip by cosmic standards. Now imagine decades, centuries, millennia. A crewed interstellar mission would be subjected to continuous radiation bombardment, day after day, year after year. Without shielding, we do not know how to build. The crew would not slowly age, they would unravel at the cellular level. Cancer would not be a risk, it would be inevitable. Robots fare better. Electronics are even more sensitive to radiation than biology. High-energy particles flip bits, corrupt memory, destroy microstructures. Every spacecraft sent beyond Earth's magnetosphere eventually degrades for this reason. The Voyagers survive only because their electronics are primitive, and because luck has been kind. But radiation is only the beginning. Interstellar space contains tangled magnetic fields, shock fronts from ancient supernovae, turbulent boundaries between gas clouds of different densities. These are regions where charged particles are accelerated, redirected, and focused. Our solar system sits inside what astronomers call the local bubble, a region of unusually low interstellar gas density created by supernova explosions millions of years ago. By cosmic standards, we live in a quiet neighborhood. Other regions of the galaxy are not so forgiving. Closer to the galactic center, stars are packed more tightly. Supernovae occur more frequently. Radiation levels rise. Gravitational disturbances from nearby stars can destabilize planetary systems, ejecting planets into interstellar space or triggering catastrophic orbital chaos. Life near the core of the Milky Way, if it exists, must be extraordinarily resilient or extraordinarily lucky. And then there is the monster at the center, a supermassive black hole with a mass millions of times that of the Sun. Right now, it is relatively quiet. But in the past, it was active feeding, erupting, launching jets of high-energy particles that could sterilize entire star systems thousands of light-years away. Here is where the speed of light becomes a shield. When something catastrophic happens far away, we do not experience it immediately. Light takes time. Radiation takes time. Death does not arrive instantly. If a star explodes 1,000 light-years away, we have 1,000 years before we even see it. That matters, but works against us. Because if something lethal happens close enough, we receive no warning at all. Light and destruction arrive together. Consider gamma-ray bursts. These are the most energetic explosions since the Big Bang itself. When a massive star collapses into a black hole, or when two neutron stars merge, energy is released in narrow beams moving nearly the speed of light. For a few seconds, a gamma-ray burst can emit more energy than the Sun will produce over its entire 10 billion-year lifetime. If one of those beams were pointed directly at Earth from within our galaxy, the result would be catastrophic. The ozone layer would be stripped away. Ultraviolet radiation from the Sun would flood the surface. Atmospheric chemistry would change. Mass extinction would follow. Some scientists believe one of Earth's past mass extinctions, around 400 million years ago, may have been caused by such an event. If it happened today, civilization would not collapse, and we would receive no warning. Because the speed of light does not advance notice, the flash and the damage arrive simultaneously. The probability is low. Gamma-ray bursts are rare, and the beams are narrow. Statistically, we are safe. But statistics are cold comfort when the failure mode is total annihilation. Now consider magnetars. These are neutron stars with magnetic fields trillions stronger than Earth's. They are the strongest magnets known to exist. Occasionally, their crusts fracture in events called starquakes, releasing enormous bursts of energy. In December 2004, detectors across Earth recorded a powerful gamma-ray flash. It came from a magnetar on the far side of the Milky Way about 50,000 light-years away. Even at that distance, the burst ionized Earth's upper atmosphere and disrupted radio communications. If that same event had occurred within 10 light-years, it could have stripped our ozone layer. At 1 light-year, it could have sterilized the planet's surface. We do not know how many magnetars exist nearby. They are dim, invisible light and hard to detect. They can remain quiet for centuries, then erupt without warning. And once again, we would only know when it was already too late. The universe does not announce its attacks. Now shift scale again to collisions. In 2017, detectors observed gravitational waves from the merger of two neutron stars. At the same time, telescopes detected a flash of light. For the first time, humanity observed the same cosmic event through spacetime vibrations and electromagnetic radiation. Two city-sized objects, each more massive than the Sun, spiraled together for millions of years before colliding. The collision produced heavy elements: gold, platinum, uranium. The atoms in your jewelry were forged in such catastrophes, but the merger also produced a gamma-ray burst. Had such an event occurred within a few thousand light-years with the beam pointed at us, the consequences would have been dire. We cannot predict where these events will happen. We cannot stop them. We cannot shield the entire planet. We can only. Distance saves us. And distance is governed by the speed of light. Now consider the scale of galaxies themselves. The Milky Way is not alone. It belongs to a small collection of galaxies called the Local Group. The nearest large member is Andromeda, a massive spiral galaxy containing roughly 1 trillion stars. And Andromeda is moving toward us at about 110 kilometers per second. This is not temporary. The two galaxies are gravitationally bound. In roughly 4 to 5 billion years, they will collide. A galactic collision is not stars smashing together. Space is too vast for that. Instead, gravitational forces tear spiral arms apart, fling stars into intergalactic space, compress gas clouds, and ignite waves of star formation. Eventually, after billions of years of chaos, the two galaxies will merge into a single giant elliptical galaxy. Astronomers have already named it Andromeda. By that time, the Sun will be a red giant or gone entirely. Earth, if it still exists, may be scorched, stripped, or consumed. But if any descendants of humanity remain, they will witness a sky transformed beyond recognition, familiar constellations erased, new stars born, old stars ejected into eternal darkness. And again, the speed of light offers no escape. We will see it coming millions of years in advance, be utterly powerless to change it. This, the pattern. The universe is violent, but slow. Slow enough to allow pockets of stability. Slow enough for life to emerge. Slow enough for intelligence to form. The speed of light enforces that slowness. It prevents catastrophes from propagating instantly. It isolates star systems like islands separated by vast oceans. That isolation gives lifetime. But the same isolation ensures that when danger finally arrives, there is nowhere to run. If a supernova threatens our region, we cannot evacuate humanity to another star. If the sun becomes unstable, we cannot flee to a neighboring system. If a black hole wanders too close, we cannot outrun its influence. We are protected by distance and condemned by it. This is true cruelty. Not that we cannot explore, not that we cannot escape, but that we are fully aware of our fragility, fully aware of the dangers, and fully aware that the walls are absolute. We live in a cell whose bars are made of space-time itself, and yet, despite this, we keep looking up. Not because the universe is safe, not because it is kind, but because knowing the truth does not stop wonder. There is a star in the night sky that could end an era. You have seen it. Even if you don't know its name, you have noticed it, an orange-red glowing in the shoulder of Orion during cold winter nights. It looks calm, ancient, almost friendly. Its name, Betelgeuse. It lies roughly 700 light-years from Earth, close enough to be visible with the naked eye, far enough to feel safely distant. And yet Betelgeuse is dying. Not metaphorically, not poetically, physically. Betelgeuse is a red supergiant, a star many times more massive than the Sun and vastly more unstable. It is young by stellar standards, only about 10 million years old, but for a star of its mass, youth burns fast. It has already exhausted hydrogen in its core and moved on to heavier fuels. Helium fuses into carbon, carbon into oxygen, oxygen into neon, magnesium, silicon, and finally, iron is the end. When a star's core fills with iron, fusion stops being a source of energy. Instead of releasing power, it consumes it. Gravity wins. The delicate balance holding the star up against its own mass collapses. When that happens, the core falls inward at a significant fraction of the speed of light. In less than a second, matter that once occupied a volume comparable to Earth is crushed into a sphere only a few dozen kilometers across. Density rises to values that defy intuition. A teaspoon of this material would weigh billions of tons. A neutron star is born. Or, if the mass is high enough, a black hole. The outer layers of the star cannot follow the collapse. They rebound violently, slamming into the contracting core and detonating outward in an explosion so powerful it rewrites the surrounding space. A supernova. For weeks, the star shines brighter than entire galaxies. For a brief time, Betelgeuse could be visible from Earth even during the day, casting shadows at night, rewriting the sky humans have known for millennia. And here is the settling part. Betelgeuse could explode tomorrow, or in 1,000 years, or in 100. Astronomers do not know. They see signs of instability, pulsations, massive outflows of gas, fluctuations in brightness. But stellar death is not punctual. It does not send invitations. When we look at Betelgeuse tonight, we are seeing light that left the star 7 centuries ago. For all we know, it has already exploded. The shockwave of light may already be racing toward us, crossing the void at the maximum speed reality allows. And we will only know when it arrives. Once again, the speed of light plays its cruel game. We cannot know the present state of distant stars. We only ever see their path. The universe does not show us what is, it shows us what was. Every glance at the night sky is an act of archaeology. Some of the stars you see no longer exist. They collapsed, exploded, or faded long ago. Their light is simply still en route, carrying obsolete news across an immense delay. This is not just poetic irony, it has consequences. If Betelgeuse explodes, Earth is safe. 700 light-years is enough distance to shield us from lethal radiation. The event would be spectacular, not catastrophic, but all stellar deaths are equal. Some stars die louder. Hypernovae, supernovae on steroids occur when the most massive stars collapse. Blue giants with masses tens, even hundreds of times that of the Sun. In these events, the core collapses directly into a black hole. Matter spirals inward, forming an accretion disk that launches narrow jets of particles and gamma radiation at near light speed. These jets punch through the dying star and fire into space like cosmic sniper rifles. If such a jet intersects a planet within a few thousand light-years, the consequences are devastating. Atmospheres stripped, surfaces sterilized, life erased. These events are rare, but not impossible, and they do not warn. In December 2004, Earth experienced a reminder of this vulnerability. Gamma-ray detectors across the planet and in orbit recorded an intense flash. It came not from another galaxy, but from within our own about 50,000 light-years away. The source was a magnetard, a neutron star with a magnetic field trillions of times stronger than Earth's, the strongest magnets in the universe. Magnetars occasionally suffer starquakes, fractures in their ultra-dense crusts. When this happens, they release colossal bursts of energy. That single flare released more energy in a fraction of a second than the Sun emits in hundreds of thousands of years. Even at such distance, the burst ionized Earth's upper atmosphere and disrupted radio communications. If that magnetar had been 10 light-years away, Earth's ozone layer would have been destroyed. At 1 light-year, the surface would have been sterilized. We do not know how many magnetars exist near us. They are dim, quiet, difficult to detect. They can sleep for centuries and then erupt without notice. And once again, the speed of light ensures that when the signal arrives, it is already too late. This is the pattern of cosmic danger. We are not warned. We are informed posthumously. Now shift perspective again away from single stars, away from explosions, and toward the structure of reality itself. The universe is expanding. We know this. But expansion is not uniform in experience. It stretches light itself. As light travels through expanding space, its wavelength is stretched. It reddens. Energy drains away. Eventually, light is shifted out of the visible spectrum, then out of infrared, then beyond radio waves, until it becomes undetectable. This means that distant objects do not simply grow faint. They vanish. Galaxies do not explode or shut off their lights. They slip silently beyond the range of possibility. There are regions of the universe whose light is still on the way, but will never arrive. And because expansion is accelerating, more regions cross this boundary every moment. The universe is not just large. It is actively deleting itself from our future. Now consider what this means for meaning. We are intelligent enough to reconstruct the universes. We can infer the Big Bang, cosmic inflation, the formation of galaxies, the birth of stars. But future observers will not have this luxury. Billions or trillions of years from now, expansion will have erased near all evidence. The cosmic microwave background will fade beyond detectability. Distant galaxies will vanish. Physics itself will become harder to discover, not because minds are weaker, but because information is gone. Reality will have edited its own history. All of this is enforced by the speed of light. It defines causality. It defines knowledge. It defines what can influence what. And this brings us to a realization that is deeply uncomfortable. The speed of light does not merely limit what we can do. It limits what can ever be known. It creates a universe where most events are permanently separated, where truths exist without witnesses, where causes unfold without effects that can ever be observed. In such a universe, isolation is not accidental. It is structural. And yet, within this structure, something improbable happened. Life. Against radiation, against gravity, against entropy, against distance, a species emerged on a small planet orbiting an unremarkable star, capable of understanding all of this, capable of knowing that it is trapped, vulnerable, temporary. And instead of looking away, it looked closer. It built telescopes, it launched probes, it encoded voices into gold and hurled them into darkness. not because success was guaranteed, but because silence was unacceptable. The speed of light may be a cage, but consciousness is what presses its face against the bars and insists on seeing anyway. Understand the final cruelty of the speed of light. We have to abandon the present entirely. We have to look forward, not decades, not centuries, not even millions of years, but into the deep future of the universe itself. A future so distant that everything familiar dissolves. Stars are not eternal. They burn fuel, and fuel runs out. Massive stars live fast and die young, exploding after a few million years. Stars like the Sun last longer, around 10 billion years, quietly converting hydrogen into helium. Red dwarfs, the most efficient stars of all, can shine for trillions of years, sipping their fuel so slowly that the universe may grow old around them. But even they will die. Eventually, every star exhausts its fuel. When the last nuclear reactions fade, the universe enters a new epoch, one without light born from fusion. No new stars. No warmth generated by stellar cores. Just remnants. White dwarfs cooling into black husks, neutron stars slowly losing energy, black holes drifting through expanding space. This is not speculation. This is the trajectory written into the equations. After roughly 100 trillion years, the final star will go dark. What remains is called the heat death of the universe, a state of maximum entropy. No temperature gradients, no usable energy, no processes capable of sustaining complexity. Matter and radiation spread thin across a vast, cold, expanding spacetime. And here again, the speed of light quietly shapes the outcome. Even if some form of life or mind could exist in that distant era, it would be trapped in extreme isolation. Distances would be unimaginably large. Signals would take longer than remaining processes could endure. Communication would be functionally impossible. Every pocket of existence would be alone. Each island of matter sealed off by expansion and light speed limits. Unable to coordinate, unable to share, unable to know whether anything else still thinks or feels. Loneliness comes fundamental. But there is something even stranger about this future, something that challenges how we think about time itself. From the perspective of relativity, time is not a universal clock ticking forward for everyone. It is woven into space-time, experienced differently depending on motion and gravity. For photon particles of light, time does not pass at all. A photon emitted by a star and absorbed by your eye experiences no duration between those events. From its own point of view, departure and arrival are the same moment, even if billions of years pass for the universe. This means that, in a very real sense, the entire history of the universe from the Big Bang to the final decay of matter exists simultaneously within spacetime. Past, present, and future are not separate compartments. They are slices through a four-dimensional structure. The Big Bang is not behind us in time. The heat death is not ahead of us in time. They are boundaries of the same object. We move through this object at a pace limited by the speed of light, perceiving only a thin cross-section we call now. This makes the speed of light more than a constraint. It becomes the rate at which reality reveals itself. It determines how fast causes can produce effects, how fast knowledge can propagate, how large a piece of the universe any observer can ever experience. In that sense, the speed of light defines consciousness itself. A mind can only know what lies within its light cone, the region of space-time that can influence it or be influenced by it. Everything else is permanently inaccessible, not just physically, conceptually. There are truths in the universe that no mind will ever hold. Events that happen without witnesses. Structures that exist without observers. Entire regions of reality that might as well be myths, because no information from them can ever arrive. This is not a failure of intelligence. It is a property of spacetime. And now we return, finally, to the present moment to us. We live at a rare time. The universe is old enough to have formed stars, planets, and life. It is still young enough that the sky is full. Galaxies are visible. The cosmic background still whispers of the beginning. Evidence has not yet faded beyond reach. We are surrounded by information. This era will not last. Future civilizations, if they exist, will be poorer in knowledge, not richer. Not because they are less curious, but because the universe will have erased its own traces. Early and confined. The speed of light lets us see the universe's beauty while denying us participation. It turns existence into observation. It makes us spectators in a cosmic drama we can never enter. And yet, this is not the end of the story. Because despite all this, despite knowing the cage is real and absolute, humanity does something irrational. Reaches. It builds telescopes to see farther. It launches probes to touch the edges of its prison. It invents theories it suspects will never be tested, simply to understand the shape of the walls. This is not practicality. This, defiance. Voyager 1 will go silent soon. Its power will fail. Its voice will fade. But it will continue drifting for millions of years, carrying a golden record music, greetings, images of beings who knew they were trapped and still chose to speak. That record is not a message of conquest. It is a message of existence. We were here. We looked up. We understood the limits, and we refused to pretend they didn't exist. The speed of light may define the ultimate boundaries of motion, knowledge, and connection, but it does not define meaning. Meaning arises in the act of seeing, of understanding, of refusing to let silence have the last word. In a universe that will one day go dark, that may be the only victory available, there is a question that physics alone cannot answer. Why does the universe allow us to see so much yet forbids from touching almost all of it? This is where equations end and psychology begins. Human consciousness did not evolve to understand galaxies. It evolved to track prey, read faces, remember paths through forests. And yet, against all evolutionary logic, the human mind became capable of grasping scales that dwarf its own existence. We can understand light years. We can imagine black holes. We can calculate the age of the universe. And the moment we do, something's inside us. Because understanding creates desire. Once you know that other stars exist, you want to go there. Once you understand that other planets may host life, you want to see them. Once you grasp the scale of the cosmos, confinement becomes unbearable. The speed of light turns curiosity into frustration. It builds a universe that constantly stimulates the mind while denying the body any way to follow. This is not how nature usually works. Most animals do not perceive unreachable possibilities. A bird does not suffer because it cannot fly to the moon. A fish does not despair because it cannot cross continents. Their perception matches their agency. Ours does not. We can imagine than we can ever reach. This mismatch may be the deepest source of existential pain. Every telescope sharpens it. Every discovery widens the gap. Each new exoplanet cataloged, each habitable zone mapped, each spectral hint of water or atmosphere increases awareness of what will never be touched. Knowledge becomes a form of loss, and yet, evolution selected for this, which raises a disturbing possibility. What if intelligence is not meant to escape the universe? What if it meant to witness it? The speed of light does something subtle. It allows observation without participation. It creates a cosmos where minds can arise, comprehend immense structures, yet remain physically harmless. A universe without this limit would be radically different. If travel and communication were instantaneous, any technological species could spread aggressively. Resources would be consumed rapidly. Stellar systems would be reshaped. Cosmic scale engineering would become inevitable. Such a universe would not remain stable for long. But our universe is conservative. It limits influence. It isolates civilizations. It slows consequences. Perhaps the speed of light is not an accident, but a filter. Not a moral one, a physical one. Only civilizations that can tolerate isolation, patience, and restraint can exist for long. Any species driven purely by expansion would burn itself out before crossing the stars. In this sense, the universe does not reward ambition. It tests endurance. Think about how we actually interact with the cosmos. We do not conquer it. We measure it. We listen to it. We infer its history from faint traces of ancient light. Astronomy is not an active science. It is forensic. We study relics, fossils of radiation, echoes of explosions that happened before our species existed. Every data set is a message from the dead, and yet we find meaning there. This suggests that intelligence may not be about control. It may be about comprehension. The speed of light ensures that the universe remains mostly untouched, even by its most intelligent inhabitants. Stars live and die without interference. Galaxies collide on their own schedules. Physics unfolds without negotiation. We are observers, not managers. This may be only sustainable role. Now consider a darker interpretation. Perhaps the universe is not protecting itself from us. Perhaps it is protecting us from the universe. Imagine a reality without light speed limits, where information about every catastrophe propagates instantly, where gamma-ray bursts announce themselves the moment they occur, where distant supernovae deliver radiation without delay. Such a universe would be lethal. Life would have no time to adapt, no buffer, no warning period, however limited. The speed of light creates temporal insulation. It delays harm. It localizes disaster. It gives a chance. But the price of that chance is confinement. We cannot escape threats. But we are not overwhelmed by all threats simultaneously. We are spared instant annihilation at the cost of eternal isolation. This is the trade. The human mind struggles with it because it evolved for environments where trade-offs were immediate and tangible. Food versus danger. Shelter versus exposure. But cosmic trade-offs span billions of years. We are emotionally unequipped to accept them. So, narratives. We imagine future breakthroughs, faster than light travel, hidden dimensions, technological salvation. We tell ourselves the cage is temporary, that the walls will eventually open. Science fiction is not prediction. It is coping. And yet, despite knowing all this, despite suspecting that escape is unlikely, we keep building instruments that sharpen the pain. We improve telescopes. We extend surveys. We search for biosignatures. We map cosmic background radiation with ever greater precision. Why? Because there is another instinct at work. The refusal to be ignorant. Even if knowledge brings sadness, we prefer it to darkness. Even if understanding reveals limits, we choose understanding over illusion. This is not optimism. It is integrity. The speed of light may define what we cannot do, but it also defines what we can be. Observers, witnesses, archivists of reality. Perhaps that is the function of intelligence in a universe like this, not to spread endlessly, but to remember. To look at a sky that will one day be empty and say, it was once full. To record that fact before expansion erases it forever. In that sense, every measurement, every image, every theory is an act of preservation, a rebellion against cosmic forgetting. The universe will not remember itself. Stars do not reflect on their deaths. Galaxies do not mourn collisions. Black holes do not archive what they consume. Only minds do that. And minds only briefly, which gives them urgency. The speed of light ensures that we cannot rewrite the universe's fate, but it does not prevent us from understanding it. And maybe that is the final test. Not whether we can escape, but whether we can face reality without turning away. There is something profoundly irrational about sending messages into a universe that will almost certainly never answer. And yet, we do it anyway. Long before humanity had any realistic hope of reaching another star, it began transmitting signals into space. Radio waves carrying fragments of language, mathematics, images. Carefully encoded introductions sent to distant suns, knowing full well that any reply, if it came at all, would arrive long after the senders were dead. This behavior makes no evolutionary sense. There is no survival advantage in greeting the void, unless the act itself matters more than the outcome. The most famous embodiment of this instinct is Voyager, not as a machine, as a symbol. Voyager 1 and Voyager 2 were not designed to reach other stars. They were planetary probes sent to study the outer worlds of our solar system. Everything beyond that was a side effect of success. Gravity assists, extra velocity, a trajectory that happened to point outward. And yet, once it became clear that they would escape the sun's influence, humanity changed how it thought about them. They stopped instruments. They became ambassadors. Each Voyager carries a golden record, a copper disc coated in gold, etched with diagrams explaining how to play it, how to decode it, how to understand the beings who made it. It contains sounds of earth, wind, rain, thunder, footsteps, heartbeats, music from different cultures, greetings in dozens of languages, images of human anatomy, of families, of landscapes, of DNA. It is a message designed for an unknown recipient at an unknown time, in an unknown context, speaking languages that may no longer exist. A message written for an audience that may never exist. From a practical standpoint, it is absurd. From a psychological standpoint, it is inevitable, because intelligence does not merely seek to survive, it seeks to be known, even if no one is listening. Voyager's golden record is not an attempt at communication. It is an assertion of presence. It says, something conscious happened here. The speed of light makes sure that this assertion will almost certainly never be confirmed. Even if another civilization were to intercept Voyager millions of years from now, the civilization that sent it may be extinct, transformed, or forgotten. The reply would have nowhere to go, but that does not invalidate the act. On the contrary, defines it. A message sent with no expectation of reply is not a request. It is a statement. Throughout history, humans have carved symbols into stone, painted caves, erected monuments whose builders knew they would not see the future they addressed. The difference with Voyager is scale. This is not a message across generations. It is a message across epochs, across extinction, across the eventual disappearance of the sky itself. And Voyager is not alone. We have sent radio messages toward globular clusters. We have encoded prime numbers and binary images into transmissions aimed at stars dozens or hundreds of light years away. We have searched for narrowband signals from others, even while suspecting that any conversation would be stretched across centuries. Why persist? Because silence is not neutral. Silence implies absence. Messages imply defiance. The speed of light enforces isolation, but it does not forbid expression. We cannot arrive, but we can announce that we tried. This behavior reveals something essential about the human mind. When faced with limits that cannot be overcome, it does not always retreat. Sometimes it shifts goals. If conquest is impossible, it seeks legacy. If interaction is unlikely, it seeks evidence. This is why we build telescopes larger than cities. Why we catalog galaxies we will never visit. Why we model universes we will never observe directly. It is not optimism. It is refusal. Refusal to let the universe be unrecorded. Refusal to let existence pass without commentary. The speed of light ensures that most of reality will never interact. But interaction is not the only form of connection. Observation is a form of connection. Understanding is a form of intimacy. When we study a distant star, we cannot touch it, but we can reconstruct its interior. We can know its mass, its age, its future. We can predict how it will die. In some sense, we know it more deeply than we know many things within reach. This is the paradox of cosmic isolation. Distance prevents contact, but not comprehension. Perhaps this is why the universe allows itself to be seen. If interaction were easy, observation might be trivial. If travel were effortless, understanding might be shallow. Limits force depth. The speed of light stretches patience into a virtue. It forces intelligence to operate on timescales larger than its own lifespan. It encourages continuity rather than conquest. This may be why science is inherently collaborative across generations. No one finishes the project. Everyone contributes a fragment. Each discovery is a relay baton passed forward, not a destination reached. Voyager, this perfectly. The people who designed it are old or gone. The people who launched it are mostly gone. The people who will receive its last signal may not yet be born. And after that, Voyager will continue alone. Silent. Moving. It will pass stars without stopping. It will traverse clouds of gas and dust. It will orbit the galaxy for billions of years, long after Earth has changed beyond recognition. Its golden record will remain intact far longer than any city, any book, any language. A fossil of consciousness, a proof that, for a brief moment, matter learned how to wonder, and may be enough. The speed of light denies us reunion. It denies us feedback, denies us closure, but it did not deny us authorship. We cannot shape the universe's fate, but we can annotate it. We can leave margins filled with notes that say, "We were here, we looked, we understood something." In a cosmos that will one day forget itself, memory is rebellion at some point. Every mind that looks into the cosmos asks the same question: where is everyone? It is not a childish question. It is not naive curiosity. It is a logical scream echoing through a universe that appears impossibly large and unnervingly quiet. This is Fermi Paradox. The universe is old. It is vast. It contains hundreds of billions of galaxies, each with hundreds of billions of stars, many of which host planets. Chemistry is universal. The building blocks of life are everywhere. By any reasonable statistical argument, intelligent life should have arisen many times. And nothing. No clear signals, no artifacts, no unmistakable evidence of galactic civilizations. Just silence. The usual explanations try to soothe us. Life is rare. Intelligence is rare. Civilizations destroy themselves. They are hiding. But there is another possibility, one that fits disturbingly well everything we have discussed. Maybe the universe full of intelligence, and maybe intelligence is always alone. The speed of light ensures that separation is not just large, it is absolute. Civilizations may bloom in distant star systems, build technologies, ask questions, and search the skies exactly as we do, but their light cones barely overlap. Their histories do not intersect. Their signals fade before they arrive. Each civilization exists in its own bubble of spacetime, surrounded by an ocean it can see but never cross. From the inside, it looks like emptiness. From the outside, if outside even makes sense, it might be crowded beyond imagination. The paradox is not where is everyone. It is, when would we ever know? Even communication is cruelly constrained. A civilization 1,000 light years away might broadcast for 1,000,000 years and never receive a reply, not because no one answered, but because responses arrive after both sides have already changed beyond recognition. A species sends greetings, it evolves, it collapses, its messages arrive to ruins. The speed of light does not just delay conversation, it destroys continuity. And continuity is essential for culture, memory, and meaning. Without it, civilizations cannot acknowledge each other's existence in real time. They cannot confirm they are not alone. They cannot even know whether their signals are being received or lost forever. This produces chilling outcome. Every civilization experiences itself as the first and the last. This may explain why the universe feels haunted rather than empty. The silence is not evidence of absence. It is evidence of isolation. Now consider the darker interpretations. Some hypotheses suggest that intelligence inevitably destroys itself through war, environmental collapse, runaway technology. Others suggest that advanced civilizations choose not to broadcast, fearing unknown threats. But these explanations assume agency. The speed of light does not. It enforces silence, regardless of intent. Even peaceful, curious, long-lived civilizations are muted by distance. Even those who wish cooperate cannot synchronize. There is no galactic conversation, not because minds refuse to speak, because spacetime refuses to carry the dialogue. This reframes loneliness. Loneliness is not a tragedy of circumstance. It is a structural feature of reality. And this brings us to a deeply uncomfortable idea. Perhaps intelligence is not meant to form networks across the stars. Perhaps intelligence is meant to experience the universe locally, in isolation, as a temporary phenomenon, like a spark flaring briefly before entropy smooths everything back into darkness. From this perspective, the universe is not waiting to be colonized. It is waiting to be noticed. Each intelligent species is a lens through which the universe becomes aware of itself for a short time. When that lens fades, awareness collapses back into silence. No accumulation, no convergence, no grand cosmic civilization. Just fleeting moments of self-reflection scattered across spacetime. If this is true, then the speed of light is not a bug. It is the rule that keeps reflections separate. The universe does not want a single consciousness dominating its structure. It allows only fragments, localized, temporary, self-contained. Each fragment, it might be alone. And it is. This interpretation is terrifying because it strips away hope for rescue, contact, or shared destiny. There is no elder civilization to guide us, no cosmic community to join, but removes fear. If there is no galactic empire, there is no galactic war. If civilizations cannot reach each other, they cannot conquer each other. The universe is violent, but locally. Cosmic threats are natural, not intentional. This does not make existence safe. It makes it. Now ask yourself, what would true proof of alien intelligence even look like? A radio signal repeating prime numbers? A structure blocking starlight? Anomalous energy use? All of these assume detectability within our light cone. Civilizations outside, it may be screaming into the void, and we will never hear them. Their entire history may unfold and vanish without leaving a single photon that reaches us. From our perspective, they never existed. From theirs, we never existed either. This is ultimate separation. Not distance, not time. Causality, and the speed of light is the gatekeeper. So when we ask, are we alone? The question itself becomes flawed. We are alone in the only sense that matters. Not because life is rare, not because intelligence is special, but because the universe enforces solitude. Every civilization gets one sky, one island of visibility, one brief window where it can understand that the universe is larger than itself, and that it will never fully belong to it. And perhaps that realization is the point. Perhaps intelligence is not measured by expansion or contact, by the ability to endure awareness without consolation, to know the universe is vast, indifferent, and unreachable, and still choose to care, still choose to observe, still choose to leave messages. The silence is not mocking us. It is mirroring us. Everywhere, minds may be staring into the dark, wondering the same thing, separated forever by the same immutable limit. The speed of light does not say, you may not meet. It says you may only know yourselves. And so we return to the present, to this exact moment. To you, reading these words on a small planet orbiting an ordinary star, inside a galaxy that will one day be torn apart, inside a universe that is slowly deleting itself. Nothing changes that. The speed of light remains absolute. The walls remain unbroken. The future remains unreachable. There will be no last-minute loophole. No miraculous equations scribbled on a whiteboard that suddenly opens the stars. No hidden dimension waiting to be unlocked like a secret level in a game. If faster than light travel were possible, the universe would look different. It doesn't. The structure of reality itself insists on separation. And yet, we are a species that understands all of this and still refuses to behave as if it means nothing. That, the final paradox. The universe tells us, in the coldest possible way, that we are temporary, isolated, and irrelevant on cosmic scales. And we, by caring anyway, we build instruments not because they will save us, but because they will tell the truth. We send probes not because they will return, but because movement itself matters. We record voices not because they will be heard, but because silence is unacceptable. Voyager 1 is still moving. Right now, its power source is weakening. Its instruments are falling silent by one. Soon, it will stop speaking entirely, but not stop traveling. For tens of thousands of years, it will drift between stars. For millions, for billions, long after Earth has changed beyond recognition, long after humanity may be gone. It will remain a small, artificial object carrying evidence that the universe once produced beings who knew the truth and acted anyway. Not conquerors, not immortals, witnesses. The golden record on board Voyager does not say we were powerful. It does not say we escaped. It does not even say we survived. It says something far quieter. We noticed that may be the only thing intelligence ever gets to say. The speed of light ensures that no mind can dominate the universe. No civilization can spread unchecked. No consciousness can rewrite cosmic history, but it does not prevent understanding. And understanding, in a universe like this, is everything. We are the brief interval where matter becomes aware of itself, where the universe looks back and realizes that it exists, even if only for a moment. Stars do not know they shine. Galaxies do not know they collide. Black holes do not know they consume. We do. And that awareness, even trapped, even fleeting, is not nothing. The universe does not offer meaning. It does not guarantee purpose. It does not promise continuation. Meaning is something consciousness creates locally, against entropy, inside the cage. Perhaps that is why the speed of light allows vision but forbids arrival. Perhaps the universe does not want to be possessed. Understood. When you look at the night sky, you are not looking at destinations. You are looking at messages from the past light that crossed impossible distances just to touch your eyes for a fraction of a second. Each photon is survivor. Each star is a memory. And you, for a brief moment, are the place where that memory is received. That is not conquest. That is communion. We may never leave this island. We may never meet the others. We may never escape the walls of spacetime. But inside those walls, something extraordinary happens. The universe becomes aware that it is vast, that it is violent, that it is temporary, and that awareness refuses to be silent. If this is a prison, then curiosity is the graffiti on its walls. If this is a cage, then understanding is the act of standing upright inside it. And if the speed of light is the cruelest limit ever imposed on intelligence, then the human response to keep looking, keep measuring, keep sending messages into the dark is the only rebellion that ever mattered. Close your eyes. Imagine the universe as it really is, expanding, cooling, fading, stars igniting and dying, galaxies colliding and dissolving, black holes swallowing the last light, and somewhere inside that vast process, a small blue planet where matter learned to ask questions. We never reached the stars, but tonight we see them. And that, in a universe like this, is enough. Andy,